All right, in this video, we want to sketch these log functions over here and then find the domain and range of them. So let's start with the first question over here. So generally speaking, a log function has a vertical asymptote at x equals to 0, and it has an x-intercept of 1. I'll do a little tiny diagram here of a basic log function with no transformations at all. So we have an asymptote at x equals to 0, and your x-intercept is 1. So what we want to do is we want to just move this asymptote and this point based on the transformations given in each question. So let's start with the first question here. I have a vertical stretch of 3, and I have a vertical shift up by 3 units. Neither of those affects my asymptote. So my asymptote is going to stay at x equals to 0. And then let's look at the key point. If I multiply the y value of this key point is 0. So if I multiply 3 times 0, I'll still have 0. And if I add 3, it's going to move up by 3 units. My sketch is just going to look like this, and the key point is at 1, 3. It was just shifted up 3 units. So my domain for this function is just x as an element of all real numbers such that x is greater than 0, just greater than my vertical asymptote. My range for all log functions is just y as an element of all real numbers. Let's try this second example over here. So over here, my graph is reflected in the x-axis and it's shifted by 6 units to the right. So first thing I'll do is I'll draw my vertical asymptote, which normally is at 0, but now it's shifted 6 units to the right. X equals to 6. And my original point is over here at 1 and 0, but it's shifted 6 units to the right as well, which is going to make it at 7 and 0. Now, a log graph normally goes up like that, but a reflection in the x-axis doesn't affect the x value, but it'll affect all the y values. It'll make it look upside down like that. My domain is, again, x is an element of all real numbers, but now my asymptote is moved to 6. So x is greater than 6, and y is just an element of all real numbers. Let's go to the third question over here. This question just has a horizontal compression by a factor of 2. That's the only transformation in this one. So horizontal stretches and compressions do not affect our vertical asymptote. So my vertical asymptote will stay at x equals to 0. My point over here is at 1, 0. If I compress it by a factor of 2, it moves to 1 over 2 and 0, because 1 divided by 2 is a half. Nothing changes with the shape because there's no reflections. My graph just looks like that, and this point over here is 1 over 2. Domain and range are the same as the original because there are no shifts or reflections. So x is greater than 0, and y is an element of all real numbers. Let's go to the fourth example here. We have a horizontal stretch by a factor of 2, because 1 divided by half is 2. And we have a vertical translation of 1 unit down. So neither of these two affect the vertical asymptote, which is going to just stay at x equals to 0. Only horizontal shifts affect our vertical asymptote. The point is going to get affected. So the point starts over here at 1, 0. If I horizontally stretch it by a factor of 2, it's going to move here to 2 and 0. And then if I move it down by 1 unit, it's going to move here, which is at 2 and -1. The graph just looks like that. That one's not perfectly smooth. I'll just fix it up a bit. And ignore that part over there. This 2, 1. Domain and range are same as the original because my asymptote is still at 0 and there's no reflections either. All right, let's go to the fifth question here. And this one, we have a vertical stretch by a factor of 4. We have a horizontal stretch by a factor of 6. And we have down by 2 units. So none of these affect the vertical asymptote, which is just x equals to 0 again. So let's have the point over here at 1, 0. If I multiply 0 by 4 because of the vertical stretch, it stays at 1, 0. And then if I horizontally stretch it by a factor of 6, it moves to 6 and 0. And then I have to move it down by 2 units. So it's over here at 6 and -2. Actually, I'm going to make it a bit closer here, just so that I can fit it. The graph looks like that. Basically, it's going to hug the vertical asymptote there. This is 6, -2. And again, same domain and range as the original because asymptotes in the same place and there are no reflections. And let's go to the last question over here. In this last question, we have a k value and a d value. Always remember to put in transformation form. If we have both, the k value must be factored out. If I factor out the -2, I'm just left with x plus 2. Now I can do my sketch. So my vertical asymptote is shifted left by 2 units. So it's at x equals -2. The original point over here is at 1 and 0, but I'm going to horizontally compress it by a factor of half, and I'm also going to reflect it in the y-axis. So basically, I'm going to multiply it by -0.5 or divided by -2. So from 1, 0, it moves here to -0.5 and 0. And I'm going to shift it left by 2 units. So it moves over here, which is basically -2.5 and 0. Since it's reflected, it's going to be on the opposite side of the axis. So that's what the graph is going to look like for this last one. My domain is going to be, since it's reflected in the y-axis, it's going to change to x is less than the vertical asymptote is -2. And my range, as usual, is just y is an element of all real numbers. If you made it to the end of this video and you found this content helpful, please hit that like and subscribe button, as I'm only 6 subscribers away from 1,000. Thank you for watching and have a wonderful day.